Hello, students. Good evening, all of you. Good evening. Good evening. Okay, perfect. So we are studying about the chapter hydrocarbons, right? So in the last class, we have started with a new chapter that is hydrocarbons. So first of all, before starting the chapter, let me launch the technical check for you. So I have launched the technical poll for you. There are any issues with my network, audio, video, you can let me know. We will sort it out and we will start. Right? Okay, I need quick response from your side. Okay, you two friends, you can use a live chat. You can answer me in the live chat. Okay, done. So let us start it. Let's start the class without wasting any time. So I hope technically everything is perfect now. So let us start it. So try to recollect the things, revise your notes. Last class, we have studied about so many reactions. So first of all, before starting new topics, so let us recall what we have studied in the last class. So you have a concept question, recall question. So question is, which one of the following cannot be prepared by Woods reaction? So what is this Woods reaction? First of all, you should know about Woods reaction. So do you remember what is Woods reactions? So I can write Woods reaction as I have an alkyl halide plus sodium. Sodium, it is highly reactive in nature. Then one more alkyl halide in the presence of dry ether. So what is dry ether? So ether we have studied. I can take ethoxy ether, C2H5O, C2H5. This is ethoxy ether. Okay. So in the presence of dry ether, we are doing the reaction. So what we are getting? We are getting alkanes. So RR, not your triple R. So I am getting alkane. So what about the speciality of Woods reactions? We can form or we can produce alkanes with even number of carbon atom. So what about alkenes with odd number of carbon atom? So generally we are not using Woods reaction to prepare alkanes with odd number of carbon atom. So in the question, what you have to check? We have to check which of the following organic compound has odd number of carbon atom. So check this one. Here we have 1 carbon. Here we have 3 carbon. Here we have 2 carbon. Here it is 4 carbon. So what is the correct answer here? That is our methane. So we cannot prepare methane using Woods reaction. So how can we prepare methane? So we will study about that. There are other reactions also to prepare our hydrocarbons or our alkanes. So we will study about that later. So you two friends in the live chat, they are giving the correct answer. So that's all about the concept question, what we have learned in the last class. So today also we will start with Woods reaction, right? So today we have to study about the preparation, some more preparation of alkanes are left. We will study about that. Then after that, physical properties of alkenes, physical properties, melting point, boiling point, solubility, etc. Then we have to study the chemical properties of alkene. This chemical properties of alkene, that is very, very important. Why? It's all about reaction. These reactions you will be studying again when next year. So it is better to study all this reaction now itself. It will be helpful in your 12th. Then last we have conformation. So what is this conformation? So we will study about that. Wait, we will study. So let us start it. So last class we have studied about Woods reaction. So today we are going to start with reactions similar to Woods reaction. So in Woods reaction, what we are taking? We are taking alkyl halide. Then another reaction that is known as Fittig reaction. He just copied from our Woods. So what he has done? So he has taken a aryl halide. So what is aryl halide? So we have an aryl halide instead of alkyl halide. So we have chlorobenzene here, chlorobenzene. So what about other things? Sodium, that is same as that of our Woods reaction. Sodium in dry ether, ethoxy ether, you can take it as. Then we have studied the mechanism or Woods reaction. So what is the mechanism? What is the intermediate form? So intermediate form is free radicals. So how to write the product directly? So remove this chlorine. Then there are 2 molecules of chlorobenzene. Then join our benzene and benzene. So this is known as biphenyl. The product is known as a biphenyl. What about Woods reaction? There are Rx, 2 molecules of Rx. We are getting the product R and R. Just join R and R. Okay, so here take the aryl group, then join them. So we are getting the product biphenyl. Then what about another one more product, that is our NaCl, Na and Cl. There are two aryl halides present, two Na. So two NaCl is formed here. So that is a reaction happen. Okay, you two friends, I hope it is clear to you. So that is about Fittig reaction. It just copied from Woods. Then after some time, Woods proposed a reaction, Fittig proposed a reaction. Now we are combining this Woods reaction and Fittig reaction. So what is that? In the first case, alkyl halide. Second case, aryl halide. Sodium in presence of dry ether. What is Woods Fittig reaction? So we have to take one alkyl halide. Next one aryl halide. Then sodium in dry ether. That is known as Woods Fittig reaction. So I have an aryl halide here. So aryl halide is present here. So what about this one? This is our alkyl halide, alkyl group and aryl group. So we have alkyl halide, halogen is chlorine, then sodium in presence of dry ether. So what you have to do? So eliminate chlorine, then join this alkyl and aryl group. So you will get like this. Suppose if R is CH3, that our methyl group, then what will you get here? So you will get like this, or benzene ring, then CH3. This is known as, so we have studied about the name. If the functional group is directly attached to benzene ring, if it is not directly attached to benzene ring, so what will be the IUPAC nomenclature? So we have studied about that. For this, an official name is given by IUPAC itself, that is known as toluene. Then what about the next one? That is NaCl. So we need this one. This is our major. Then here we have biphenyl. So Woods reaction we have studied. Next one, Fittig reaction. Then we are combining Woods reaction and Fittig reaction. So what is the name of that one? Woods Fittig reaction. First case, alkyl halide. Second case, aryl halide. Third case, we are taking one alkyl halide, one aryl halide. So I hope this one is clear to you. Woods reaction, Fittig reaction, Woods Fittig reaction, right? So you have to just take the alkyl part, join them together. Aryl part, join them together. One alkyl part, one aryl part, join them together. So that is all about these reactions. Okay. Next reaction. So remember, we are studying about the preparation of alkanes. Next one is decarboxylation reaction. So what do you mean by this decarboxylation? D means removal or elimination. So what we are eliminating here? We are eliminating our carbon dioxide. So we have to eliminate our carbon dioxide. Then we will get our alkane. From where we have to eliminate carbon dioxide? Let us study about that. So what is this RCOOH? We have studied about functional group. COOH means that is an acid. It is a carboxylic acid. So we have a carboxylic acid. This process is also known as soda lime process. Why it is known as soda lime? So what is the soda lime? So we have to understand that one. NaOH plus CaO. That is known as soda lime. So here we are taking soda lime. So this is also known as soda lime process. Decarboxylation, that is elimination of carbon dioxide. What is carboxylation? So we have to add carbon dioxide. So we are taking a carboxylic acid. Here we have a carboxylic acid, then NaOH and CaO. We are heating that one. So what is the product obtained? We are studying about the preparation of alkenes. So product must be, one product must be our alkane. Then some more products are obtained. Na2CO3 is formed, H2O is formed. So in short, how to find the product in decarboxylation reaction? So very simple. So we have to eliminate carbon dioxide. So remove that CO2. Then we have R. Then we have H. They're far away from each other. Join them together. So we will get RH. RH means that is an alkane form. If R is CH3, you will get CH3, then 1H. What is that? Our simplest alkane. That is methane is formed here. Methane is a product obtained. So that is how you can write the product directly. Within a short period of time, you can write the product. Then what is happening? So what is the mechanism here? So what do you mean by this mechanism, sir? Mechanism means what are the products involved in the reaction? This reactant is not getting directly converted into product. There are some intermediate state. There are some steps present. So we have to study about the step. Then it will be good for you in the next year. So let us study about what is happening here. This is also known as soda lime process. So let us study about the mechanism. So what is mechanism? Here we have RCOOH, that is an acid. So NaOH, that is our base. Okay, in 10th standard, you have studied acid-base reaction. What is a product obtained? You will get a salt plus water. So that is a product obtained, right? So which salt is formed here? Here I can write it as RCOO minus, then Na plus. Then what about water? Here we have a hydrogen from here, then OH from here. So we will get water, right? So we have sodium salt. We have sodium salt of carboxylic acid. So this is known as sodium salt of a carboxylic acid, Ca. That means carboxylic acid. Then what is the next step? So this is elimination of water. I can write Na plus here also, no issues, right? Then next step, we have CaO. We are heating that one. So in this step, so what is happening? This is coming to here. So double bond will be formed between carbon and oxygen. So what is the valency of carbon? It is tetravalent. Here, check it. Check this one. 1, 2, 3, 4, 5. 5 bonds. That is not possible. So this R group is saying I am leaving tata bye-bye to our carbon. So this one is leaving with all the electron. If it is taking the electron, what will be the charge on our R group? That is R minus, right? Carbanion, I can say. So R minus is formed here. Then what about this portion, this portion, this portion? That is C double bond O. Here also double bond O. CO2 is formed. So R minus and CO2 is formed in this step. So first step, it is like your acid-base reaction. Acid-base reacts to form salt and water. Then second step, we have sodium salt of carboxylic acid. Leave that Na plus. We know we need only negative part. This bond is coming here. Then carbon should be tetravalent. Then R is saying tata bye-bye. R is taking the electron from that bond. So if it is taking the electron, negative charge, R minus and CO2 will be formed, right? Then what is happening next? Next, we have water. This is happening in aqueous. Aqueous means water. Water is present. So in water, I can write it as H plus and OH minus. So here R minus, here H plus. So they are combining together, opposite charge, R minus and H plus. So I will get RH. RH means our alkane. So this is a process. This is a mechanism. These are the steps involved. Then, so what about Na2CO3? What about water? Here, water is formed from here, right? So water is one byproduct, we can say. What about Na2CO3? So I will explain that. Here we have OH minus. OH minus is present. So OH minus is present. Then Na plus is also present, right? Here we have an Na plus. Then NaOH will be formed. NaOH. This NaOH can react with our carbon dioxide. From where we got carbon dioxide, sir? So here we have carbon dioxide. So I will get Na2CO3 also, Na2CO3. So I got alkane, I got Na2CO3, I got water. That is decarboxylation reactions. What we have to do? RCOOH. Then remove the carbon dioxide, R and hydrogen far away from each other. We have to make it close, RH, that is our alkane form. So using decarboxylation, we are getting methane also. Woods reaction, odd number of carbon atom, it is not that much possible. Mixture of products will be obtained. Here we can prepare methane also, right? One more thing you have to remember. One more thing. R, that is alkyl group. Suppose R is our CH3. R, that is CH3 methyl group. Then can you tell me how many carbon atoms are present? How many carbon atoms are present? Here, how many carbon atoms will be present? Are these there? So alkyl group, that is CH3, 1 carbon, COH, 1 carbon, right? 2 carbon atom. So what about the product? In product, there is only 1 R, that is our CH3. So in the reactant, 2 carbon atom. In the product, only 1 carbon atom. So there is decrease in the number of carbon atom. So we can also call it as step down. We can call it as step down reaction. Step down means there is decrease. We are coming down. Okay, step down reaction. So that is our decarboxylation reaction. If it is clear, so I will give you some examples. You have to tell me the product. Adi, you can give me the answer in the chat box. So what is the answer for this one? So leave the mechanism. So what is a shortcut to find the answer? So we have ethanoic acid. How many carbon atoms are present here? There are 2 carbon atoms present here. What about the product? The product should be what? The number of carbon atoms should be less than our reactant. So I have CH3 decarboxylation, remove one carbon dioxide. So I am removing this carbon dioxide, then CH3 and H. So what is formed here? CH3H. What is that? That is our methane. So methane is formed. So we are interested in methane only. Other byproducts, it is also there. You can find it out easily. Same thing, right? That is ethanoic acid to a methane. Alkane is formed. That is decarboxylation reaction. One more example for you. I have butanoic acid. Butanoic acid means there are 4 carbon atoms. So 4 carbon atoms are present here. So what to do? Remove the carbon dioxide. This is also known as soda lime process. Why? NaOH plus CaO. That is our soda lime. So what is the product obtained? CH3H7. Remove carbon dioxide. Join the hydrogen. So I will get C3H8. What is the C3H8? C3H8 means our propane is obtained. So propane, how many carbon atoms? There are 3 carbon atoms present. So 1 carbon less than the reactant. So you two friends, give me the answer in the live chat. So propane is obtained from butanoic acid. So these are the some examples for decarboxylation reaction. I hope this is pretty much clear to you. Decarboxylation reaction. If it is clear, give me some thumbs up or something. I can understand, right? So decarboxylation, removal of CO2 in the presence of NaOH and CaO. So different steps, I have explained that. So if it is clear, you can give me the correct answer. So sodium salt of carboxylic acid, that is RCO minus Na plus, right? That is sodium salt. Sodium salt, we have studied the mechanism RCO minus Na plus. On heating with soda lime, what is soda lime? That we know, right? NaOH and CaO, that is known as soda lime. Give alkanes containing dash than the carboxylic acid. So the question they're asking about the number of carbon atom in the product. So 1 carbon more than the carboxylic acid, 1 carbon less than, 2 carbon less, either A or B. So which is the correct answer here? So which is the correct answer in the chat box? You can give me the correct answer. Okay, I'm getting answers from some students. Right. Yeah, you are pretty much correct. So 1 carbon less. So that is why we are calling it a step down reaction. So that is a one very simple thing. So very simple questions also you will get. So you should be clear about the thing, step down reaction. What is decarboxylation? What are the reactant? What are the reagent? What is the product obtained? What are the byproducts obtained? Okay, so that is one more method about preparation of alkenes. So decarboxylation, that is finished. Woods reaction, that is finished. Then Fittig reaction, Woods-Fittig reaction. So in between, I have explained that one also. Then one more method for the preparation of alkenes. There are a lot of methods for the preparation of alkene. So we will take limited number of preparation only. Sir, what about other reaction? Next year, full organic chemistry is waiting for you. This is just the basic. So next year, you will study about other methods of preparation of alkene. So in different chapters, you will study about the reactions. In that, in some reaction, alkanes will be formed. That is a methods of preparation, right? So that is all about decarboxylation. So one more, that is Kolb's electrolysis. So what do you mean by this electrolysis? I'm passing electricity. So there is an aqueous solution. I'm passing electricity. Some chemical change will occur. That is known as electrolysis. Then this is Kolb's electrolysis used for the preparation of alkene. So what is happening here? So this is a general representation, electrolysis. Okay, in electrochemistry chapter, you will study about this electrolysis in a detail. Okay, so here positive, this is positively charged electrode, positive charge, you can see connected. So positively charged electrode, that is the anode here. So negative terminal, this electrode is connected to negative terminal. So I can say it as negatively charged electrode, that is my cathode. Then the solution, aqueous solution, we have cation, that is positively charged, anion, that is negatively charged. So positively charged ions will be moving towards negatively charged electron. So here I have anion, negative to positive. So anion is moving towards anode. Then cation, positive charge, the ions, it is moving towards cathode. So this is our electrolytic solution. In that we have cations and anions present. There are 2 electrodes, one is cathode, one is anode. So that is about electrolysis. We are passing electricity. Some chemical changes happening here. So what about Coles electrolysis? You will study about electrolysis later, okay? Electrolysis. So what about basic definition? So reduction. So generally there is cathode, general, okay, general definition. So reduction will be happening at cathode. So I can call it as red cat. So this is a red cat. Then oxidation will be taking place at anode. So I can say anox, ox, right? So anox, red cat. Then also oxidation means oxidation is loss of electron. Reduction is gain of electron. I can call it as oil rig. Oxidation is loss of electron. Reduction is gain of electrons, right? So you have to remember red cat, reduction at cathode, oxidation at anode, anox and red cat. And oxidation is loss of electron, reduction is a gain of electron. So that is the basic definitions about this one. So let us study about Coles electrolysis. What is Coles electrolysis? So I'm taking sodium salt of carboxylic acid. So RCO minus Na plus. So sir, how can we write potassium salt of carboxylic acid? So I can write like this one, RCOO minus K plus, that is potassium salt of carboxylic acid. Then I am taking it aqueous solution. That means water is present. I am doing electrolysis. Then I will get some product at cathode and anode. So what is formed? We are studying about methods of preparation of alkane. Of course, alkane should be formed, right? So here one alkane is formed. Then we have carbon dioxide, carbon dioxide. Last reaction also we have removed carbon dioxide. Here also we have carbon dioxide present. So carbon dioxide, that is very, very important, right? Okay, let us find out the mechanism. So what is happening here? First, we have sodium salt of carboxylic acid. It will dissociate to form what? I'm taking RCO minus Na plus. It can dissociate to form RCO minus plus Na plus, right? At anode, this is taking place. So this is our anion, this is our anion. So anion is moving towards our anode. Then what is taking place here? Then we have oxidation, anox, anode, oxidation. Oxidation means loss of electron. So here we have a negative charge, right? So it is losing one electron, right? Then what is happening here? This is a loss of electron. Oxidation is taking place at the anode. Then there is an unpaired electron present here, right? In the next step, there is homolytic cleavage. Homolytic cleavage means, so they are breaking the bond. Then number of electrons, that is same for both the species. Homolytic cleavage. If homolytic cleavage is taking place, what is formed? What is a reaction intermediate? That is our free radical. So here one free radical. Here also one free radical. Then this R is saying tata bye bye to our carbon. So it is leaving the system. Then what is happening? Here this free radical and this one bond is formed. So double bond is formed. So what is formed? Carbon dioxide is formed here. Then what about this one? One free radical is formed. R free radical is formed here. So which are the products obtained? R free radical plus carbon dioxide. Of course, that is a gas. If free radicals are present, what is the nature of free radical? It will try to find another free radical and combine together, right? Then I can write it as R free radical combines with another R free radical to form RR. What is RR? That is our alkane. So this is a reaction taking place at the anode. Actually, in the solution, we have RCO minus and water also, water. In water, there is H plus and OH minus. There are two anions, right? So why only RCO minus is going towards our anode? Because its discharge potential is very low. So it is running very fastly and it will reach the anode first. Okay, then oxidation will take place. Then which are the cations present here? We have H plus and Na plus, H plus and Na plus. Here H plus, it has low discharge potential. In electrochemistry, you will study about this one. It has low discharge potential. So H plus will be running fastly towards our cathode. So cation is moving towards our cathode. Then at cathode, what is happening? Red cat. That means reduction is taking place at our cathode. Reduction means that is oil rig. Oxidation is loss of electron. Reduction is gain of electron. So H plus will accept one electron to form our hydrogen. Then hydrogen and hydrogen, they can combine to form H2. So what is formed at cathode? This hydrogen gas. hydrogen gas is formed at our cathode. What about our alkane? Alkane anode. How to remember? A. So alkane is formed at anode. Then carbon dioxide is formed at anode. Then what about hydrogen gas? It is formed at cathode. So this is our coarse electrolysis. You have to remember red cat. Then anodes. Then oil rig. Oxidation is loss of electron. Reduction is gain of electron. That is it. Okay. At anode, at cathode, what is forming? There are actually, for coarse electrolysis, different mechanisms are proposed. In NCERT, different is given. In other books, it is different mechanism is given. So it is correct. Okay. In NCERT also it is correct. This is also correct. Okay. That's about our coarse electrolysis. We are doing electrolysis. We are passing electricity and some chemical changes taking place. Then alkane is formed here. Carbon dioxide is formed here. Alkane is formed at anode. At cathode, hydrogen gas is liberated. So that is all about our coarse electrolysis. I hope this is clear to you. Isn't it? Coarse electrolysis. Are these present? Are the okay? Great. So that's all about coarse electrolysis. So that's all about the preparation of alkanes. I still repeat, there are so many methods for the preparation of alkanes. Using Grignard reagent, you can prepare alkanes. But this is just the beginning. Okay, chapter 2 is waiting for you. Okay, this is the beginning. You will study about all those reactions the next year. Let us study about basic things only this year. This year, reaction mechanism also, it is not given that much in detail because you are starting the journey, right? Then next one, that is about the preparation, properties of alkanes. So there are physical properties, there are chemical properties also. So first, let us find out what are the physical properties of alkanes. So alkanes, right? Alkane means single bond is present. So I'm writing CH4, that is methane, simplest alkane present, carbon and carbon. Or I can write CH3, CH3. What about polarity? If it is polar or whether it is a non-polar, carbon, electronegativity difference? No, we can say 0. What about carbon and hydrogen? Between carbon and hydrogen, we are assuming that electronegativity difference is approximately 0. It is not actually 0. Okay, only small differences. So we can say our alkanes are non-polar in nature. They are non-polar, not polar. Polar means some electronegativity difference is present, then some partial charge will be developed. So no partial charge is developed in our alkanes. So we can call them as non-polar in nature. Okay, then you have studied like dissolves like. So what is the point? Like dissolves like dissolves like dissolves like. If it is non-polar in nature, it will be dissolved in non-polar solvent, right? So non-polar in non-polar is dissolved in a non-polar solvent. What about water? Water, what is that? H2O, oxygen and hydrogen. There is electronegativity difference, delta minus, delta plus. It is polar in nature. So what about these alkanes in water? Is it miscible or not? It is not miscible in water. It is immiscible in water. Suppose oil in water, it is not miscible, right? So polar dissolves in polar. So water, it is polar. Our alkanes are non-polar. So non-polar dissolves in non-polar solvent. Okay, in alcohol, we can dissolve that. In ether, we can dissolve that, but not in water. So it is hydrophobic. These alkanes, they fear our water. So water, hydrophobic. There is phobia, fear of water. Okay, poor guy, right? Alkanes, they're immiscible with water. Then boiling point. We are increasing the temperature. Then a certain stage will reach the vapor pressure that is equal to atmospheric pressure. That is known as a boiling point. If I'm increasing the molecular mass, initially I have a small alkane with small molecular mass, right? Then after that, big guys are coming. Their molecular mass, their size is increasing. The size is increasing, boiling point also increases. Why? The van der Waals force of attraction between these molecules increases. If force of attraction increases, it is very difficult to boil that one, right? We have to break all these bonds, then only liquid to gas, right? So boiling point increases with increase in molecular mass. Then at room temperature, these alkenes, lower members means C1 to C4, that is our methane. ethane, propane, butane. They are gas. Gas means the force of attraction between them is very weak. Actually, Van der Waals force of attraction that is already weak in nature. So very weak and they are far away from each other. So they will exist as gases, right? Then higher members, I can say C5 to C17, C5 to C17. They are somewhat closer. Why? The force of attraction. Van der Waals force of attraction is somewhat strong. So they are coming close. So they are existing in liquid state. Then higher members, that is carbon, number of carbon greater than 80, greater than 17. They are existing solid state. That means force of attraction between these molecules, that is very high. Van der Waals force of attraction is very high. So that is the physical state: gas, liquid, solid. Lower members gas, higher members they exist in solid state. So these are the general physical properties: boiling point, then their existent physical state, polar or non-polar in nature. Okay, very simple. Okay, so these are the general information. No one will ask about this one in entrance examination, but it's very important that you should know about all these basic things, right? Then some more example. So I'm giving a question for you. So compare the boiling point of normal pentane, isopentane, and neopentane. So first of all, if you have revised GOC, IUPAC nomenclature, then only you can write what is isopentane, what is neopentane, what is normal pentane, right? So you have to compare the boiling point of these three. How can you do that? So try it. I will give you 30 seconds. You have to try it. You have to guess. You can guess. If you don't know, you can guess. No issues. In the class, you can guess. But in the entrance examination, don't guess, okay? You will get negative mark. Here you can guess. So 1, 2, 3, which one has highest boiling point? That is a question for you. So boiling point, highest, lowest. So can you give me the answer for this concept test? Very simple, 30 seconds. Already 20 seconds it is over, right? So you can give one highest for which one? 1, 2, 3. Which one has highest boiling point among these three? Then I will explain what is the reason behind that. So I will explain about the reason. Okay, fast. You two friends, you can give me the answer in the live chat. So I'm waiting for your answer. So what is that? So let us try it out. So first of all, you have to write the structure of normal pentane, isopentane, and the neopentane. So this is normal pentane, that is 5 carbon atoms are present. So what about isopentane? So this is our isopentane. One branch is present, right? So this is our isopentane. So what is the name of isopentane? That is 1 to 2nd position. There is a methyl group. So 2-methyl butane. So IUPAC nomenclature, entire IUPAC nomenclature we have studied, right? What about neopentane? Neopentane, one CH2 group is attached to this carbon. This is a quaternary carbon, right? So this carbon is a tertiary carbon atom. So we have studied primary, secondary, tertiary, and quaternary carbon atoms. And the hydrogen also we have studied. So this is the third one. Now we have to check the surface area. So first one, okay, pentane, isopentane it is there. Then check this one. This is like a sphere or drop, water droplets. You might have seen that in physics. You have studied surface area of the drop, that is very small. So sphere, surface area is very less. So what's the connection between boiling point and the surface area? So here boiling point, that is proportional to surface area. The surface area is decreasing, then a boiling point will also decrease. So we have to provide only less temperature. In the case of normal pentane, straight chain, surface area is very high. So what about boiling point? Boiling point is very high. If branching increases, surface area decreases, boiling point also decreases. So now you can tell me 1, 2, 3, which one has highest boiling point? Straight chain or branched one? Which one has highest boiling point? So you can tell me the answer in the chat, right? So the correct answer is this one. Normal pentane, surface area high, so boiling point is high. Neopentane, it is like a sphere. In physics, you have studied surface area is very low. So I can say boiling point is very low. So first one normal pentane, second one isopentane, and third one neopentane. This point, boiling point is directly proportional to surface area. Next year also you will repeat. In each and every chapter, next year in your 12th, you will study about physical properties, chemical properties. In that physical properties, we have to study about boiling point. So boiling point, that is directly proportional to surface area. This point you have to use next year also. So these things are very important. The basic things are very important for you. So that is a very simple question for you. You have to remember this point. Now, physical properties. Physical properties, that is not that much important. What about chemical properties, sir? Chemical properties is very, very important. So let us study about some chemical reaction. So we have alkane. So we are adding something, some catalyst is present. So reactant will be converted into product, right? So chemical reactions we have to study about. So we are going to study about chemical properties of alkanes. So let us start with general things about alkanes. Generally, I'm saying generally, okay. It is not always like this. Alkanes are generally inert towards acids, bases, and oxidizing reducing agents. Oxidizing agents, redox reaction chapter, reducing agents, right? Then, some more point. However, generally they are very inert. They're simply sitting there. They are not ready to do any work. They are not ready to react. But under certain conditions, certain special conditions, they are ready to react. So like you, studies, right? So no one is asking anything, then you will simply sit there. If some special conditions, some exams are coming, board exam, then you will be energetic, you will be ready to work. Similarly, alkanes also are doing like this. So alkanes, reactions of alkanes. First one, substitution reaction. Sir, substitution reaction. Actually, we have studied about substitution reaction. So do you remember where we have studied substitution reaction? Last chapter, IUPAC, then GOC, then certain reaction, substitution, elimination, addition, then free radical, nucleophilic, electrophilic, we have studied substitution. So last time, actually this organic chemistry, it is a continuous thing from last chapter, basic principles of organic chemistry, hydrocarbon. If you have not studied GOC, then you can't study hydrocarbon in detail. You can just study that through the surface only. Substitution reaction, what is that? Okay, our champion, world champion, Lionel Messi. So Lionel Messi is coming into the ground. At that time, someone should be go out of the ground. Messi in, Di Maria out. That is substitution. In football, there is substitution. There is a board. Similarly, in chemistry also there is substitution. Someone is going to come inside. So someone should be left. They should go outside. So what about substitution reaction? We have alkane. In alkane, carbon is present, hydrogen is present, right? Then one or more hydrogen atoms of alkanes can be replaced by, can be halogens. So Lionel Messi, this is our Messi, that is halogens, Lionel Messi, or nitro group and sulfonic acid group. Then what about hydrogen? This is our Maria, Di Maria, Angel Di Maria. Okay, so Di Maria, Messi. Messi in, Di Maria out. Hydrogen out, halogen, nitro group, sulfonic acid group, they are in. So let us study about that. If halogen is coming, then that type of reaction is known as halogenation, right? So how to write this one? So starting we have alkane, then we are adding X2. What is X2? That is halogen. It can be chlorine, Cl2, right? Then how to write the product? So alkane, there is one hydrogen. Remove that hydrogen. Then in that place, add one halogen. So that is a reaction. So look at here, alkane CnH2n plus 2. Here CnH2n plus 1 only. So we have eliminated, we have substituted one hydrogen. So in that place, we can see one X, that is our halogen. Then one chlorine is waiting there. One hydrogen that is substituted. So they will combine together. So what is from HX? If I am taking chlorine, HCl will be formed. So that is our substitution reaction, right? So substitution, X is our halogen. Then what about this reaction? So what is the mechanism involved in this reaction? That is, substitution reaction proceeds through free radical mechanism. So here free radical. So what is the intermediate form? That is our free radical. So we have studied free radical, right? R free radical we have studied. CH3, this is our methyl free radical. So we have to study about the mechanism of the reaction. So what is happening here? So let us study about the mechanism of halogenation. There are three steps. First one, we have to start it, right. So that is known as initiation. So first step, that is known as initiation. So we have halogen, we have chlorine. I am writing it like chlorine, chlorine. Then in the presence of sunlight, that is H nu or sunlight, sunlight. Then what will happen? Homolytic cleavage. Homolytic cleavage is indicated by fish hook arrow. Then this chlorine will get 1 electron, another chlorine will get 1 electron. This is initiation, starting. So homolytic cleavage is taking place here. So what is a second step? So second step, I can write it as chain propagation. First one is chain initiation, then chain propagation. So what is happening here? I have CH4, I have CH4 present. Then one free radical, chlorine free radical is coming here. Then in this case, carbon, hydrogen, hydrogen, hydrogen. Again homolytic cleavage. Then what is formed? CH3 free radical plus H free radical. Then this H free radical and Cl combines and our CH3 free radical is left here. Okay. Then this CH3 free radical will approach another chlorine. Then again homolytic cleavage. We can show it using fish hook arrow. Then what is happening? Cl free radical, Cl free radical. Then CH3 free radical and Cl combines to form CH3Cl plus a chlorine free radical. It will continue. Okay, then it will go to another one. Then again, reaction will continue. Suppose I want to end the reaction. So chain initiation, okay. Chain propagation, it is going on. I want to terminate the reaction. So third step is chain termination. Chain termination. So here what is happening? Free radicals. If I end all the free radical, then reaction will not proceed. I will terminate the reaction. Suppose I have chlorine free radical. I'm reacting it with another chlorine free radical, then Cl2 will be formed. So there is no chlorine free radical in the reaction mixture. So reaction is terminated. Suppose I have CH3 free radical present. It reacts with another CH3 free radical to form CH3. Then no CH3 free radical left. Suppose CH3 free radical is left and one chlorine free radical is present. I'm reacting them to form CH3Cl. Now there are no free radicals left. So there is no propagation. So first step is initiation. Second one is propagation. Third one is termination. This is a general mechanism, simplest mechanism for halogenation, right? Here homolytic cleavage, free radicals are formed. So intermediate, that is free radical. So I can call it as free radical mechanism, right? So that is all about the mechanism of halogenation. So very simple for you: initiation, chain propagation, or chain termination. Different products can be formed here. Okay, this is the simplest thing, simplest steps, right? So that's about mechanism of our halogenation. So what is next? Again, there are so many chemical properties left. We have to study about each and every chemical properties. So let us check the next one, halogenation. So let us study about some more points about halogenation. Reactivity of halogen towards alkane. So I'm taking alkane, then halogen is coming, reaction is taking place, right? What about different halogens? I have fluorine, I have chlorine, I have bromine, I have iodine. What about this fluorine? Fluorine, that is highly reactive in nature. It is not possible to control the reaction. So usually we will do the reaction between alkane and chlorine in the presence of sunlight. In the presence of sunlight, homolytic cleavage will take place. Bromine and iodine also, it is somewhat okay. Generally, we will take chlorine. So reactivity order, fluorine, it is highly reactive. Iodine, it is very, very, very low reactive. Then rate of replacement of hydrogens of alkenes. So rate of reaction, what about the rate of reaction? Which one is faster? So I have tertiary alkane, secondary alkane, then primary alkane. You know, tertiary, secondary, primary, right? That is carbon, carbon. One carbon is attached to another carbon. Okay. Then let us check it out. So which one is more reactive? What about the rate of reaction? If I have tertiary alkane, it is more reactive towards halogenation. Why? So what is the intermediate form here? Free radical is the intermediate form. Based on the stability of intermediate, we can say the rate of the reaction. If some stable intermediate is formed, then this reactant has a tendency to form the product. If the intermediate is not stable, then slowly this reaction will happen. Okay. So it depends upon the stability of intermediate. Suppose in the last example, we have a free radical form. So what is that free radical? CH3 free radical. So I can write it as carbon, hydrogen, hydrogen. Then that is methyl free radical. What about tertiary free radical? That is carbon, one CH3, one more CH3, then third CH3. There is free radical. Actually, free radicals, they're electron deficient. They need electrons. What about CH3 group? CH3 groups, they are ready to give electrons. If they are ready to give electron, that means it will increase the stability of free radical. So tertiary free radical or methyl free radical, which one is more stable intermediate? Of course, our tertiary free radical, right? Why? Due to the presence of CH3 group. CH3 group, it can show a plus psi effect, plus psi effect. Plus psi effect means, so that we have studied in the last chapter. It is ready to give the electrons. It is very rich. It is ready to donate the electron to poor free radical. So radical forms is more stable, tertiary, secondary, primary. So if I take tertiary alkane, then rate of halogenation will be very high. So that is a point here. Radicals formed is more stable. Then again, I have explained fluorination. It is too violent. So it is very difficult to control this fluorination. So this is about halogenation reaction. Then 3 steps: chain initiation, chain propagation, and chain termination. These are the 3 steps. That is a mechanism. Then radicals, free radicals are formed. Based on the stability of free radical, we can say the rate of reaction, rate of halogenation. How, which alkane is reacting more fastly towards our halogen. So that is all about our halogenation. Okay, Bharat. Okay, great. Then combustion reaction. So what about the combustion reaction? So what do you mean by this one? That is oxygen is present. So reaction with oxygen. So complete combustion means complete oxygen, sufficient amount of oxygen is present. Then what are the products obtained? Okay, Bharat is listening. Great. So carbon dioxide is present. Then we have H2O, that is our water. So these are the products obtained: carbon dioxide, water. Then immense amount of heat is released here. So combustion. So what do you mean by this one? So we have to write the reaction. So general reaction is, we have an alkane. What is the general formula? CnH2n plus 2. So that is a alkane present here. Then plus 3n plus 1, 2. Sir, what is this? So there's a trick, okay, how to balance a reaction easily, how to balance the combustion reaction easily. So CnH2n plus 2, that is our alkane. Then this is our oxygen. So which are the products obtained? That is carbon dioxide and water. Then let us check it out. I am taking our methyl CH4. So what is the value of N? That is only 1 carbon plus oxygen. How many oxygen is needed for complete combustion? 3n plus 1. That is N is equal to 1. 3 plus 1, 4. 4 divided by 2, that is 2. 2O2. It gives CO2. How many CO2? Here number of carbon, that is N, that is 1. So I can write 1 CO2, or you can simply write CO2 plus N plus 1. What's the value of N? 1. 1 plus 1, that is our 2. 2H2O. That is a general reaction. So if you remember this one, general reaction, you can write the combustion reaction of any alkane. So I will give you one example. So C3H8. So N is equal to 3. So 3 into 3, 9. 9 plus 1, 10. 10 divided by 2, that is 5. 5O2. So which are the products obtained? That is CO2. How many CO2? That is the value of N. That is 3 CO2. Plus N plus 1, 3 plus 1, that is 4 H2O. That is our combustion reaction. And this is a general equation. If you remember the general equation, it will be very easy for you. Right? So that is our combustion reaction. Then a concept test for you. If you understood the point, you have to give me the answer. I have hexane. What is hexane? It is an alkane with 6 number of carbon atoms. Then write the combustion reaction. So how to write the combustion reaction? Which are the products obtained? Carbon dioxide and water. That is a product obtained. Then combustion means reaction with oxygen. Then you have to write the equation. So very simple. C6H14 I have. Then N value, that is 6. Then 3N plus 1. 6 into 3, that is 3N plus 1. 3N plus 1 divided by 2 oxygen. So what is that? 6 into 3, 18. 18 plus 1 divided by 2, that is our 19 divided by 2 oxygen. Right. What about carbon dioxide? That is a value is N. So what's the value of N? That is 6. Then here it is N plus 1. 6 plus 1, that is 7. 7H2O. So this is a equation. This is a balanced equation, right? If you remember the general reaction, you can write any reaction of alkanes with oxygen. That is our combustion reaction. Or you can also write it as 19 by 2 is there. It is not looking beautiful. So I'm multiplying the whole equation with 2. Then what will you get? 2C6H14 plus 19O2. It is giving 12 CO2 plus 14H2O into 2. 6 into 2, 12. 7 into 2, 14. Then 2 into 19 by 2. That is 19, right? So this is the general equation. This is the equation for the combustion of hexane. I hope this is clear to you. So very simple, right? So this is very useful next year also. Then in some basic concept also, we have studied how to balance a reaction, how to balance the combustion reaction. Okay, I hope it is clear to you. This one, very simple reaction. So combustion reaction, that is done. We have to study about some more chemical properties. So chemical reactions given by our alkanes. So let us study about that. It's very important, right? So controlled oxidation. Last case, sufficient amount of oxygen was present. Here it is controlled. Okay, I'm giving some amount of oxygen only. Example for you. Okay, then CH4, what is that? That is our methane. Oxygen O2 is present. Control. I'm using a specific catalyst also. So copper is here. Then temperature 523 Kelvin. 523 means higher temperature. Then what about pressure? 100 atm. 100 atm means pressure is also very high. So in this case, in the presence of this copper, then conditions are 523 Kelvin and 100 atm. So what is the product obtained? CH3OH. And alcohol is obtained. What is the name of this one? Methanol. So that is controlled oxidation. Suppose I'm taking methane, I'm taking oxygen also, but I'm changing the catalyst. I'm changing the temperature. I'm changing the pressure. Then what will happen? Here I have CH4, then I have O2. Here, the catalyst is different. I'm heating that one. Here I have oxide of molybdenum. MO means that is molybdenum. Then what I'm getting? Methanol, HCHO. So I'm getting an aldehyde here. So aldehyde plus water. So if I change the condition, if I change the catalyst, if I change the pressure, if I change the temperature, then different products are obtained. So reactant, that is our methane and our oxygen. Right. So one more example. Here I have ethane present. Ethane is present here. Then reaction with oxygen. This is controlled oxygen. If it is normal oxidation or our combustion reaction, then carbon dioxide and water will be formed. Here what is formed? Here ethanoic acid. So carboxylic acid is formed here. The conditions are different. So here I'm heating it. CH3CO twice Mn. Manganese is present, right? Then water is also obtained. So ethanoic acid is a product formed here. So different condition, different products are obtained from our methane and oxygen. So this is control. There are certain regularities. I'm providing different catalysts for different reactions. So different products are also obtained here. So that is all about our controlled oxidation. So I hope controlled oxidation is clear to you, right? So that is about controlled oxidation. So we are studying about what? We are studying about chemical properties of alkanes. So in the chapter, alkanes are the alkenes, alkynes. The last some benzene, aromaticity we have studied, right? So that we will study later. Okay. Then one more, that is our isomerization. Isomers we have studied. So I have normal alkanes. I'm heating that in the presence of anhydrous AlCl3. This anhydrous AlCl3, that is very important. So next year you will study about so many reactions in which AlCl3 is involved. It's like a Lewis acid. Okay, so AlCl3 and HCl are present. Then isomerized to branched chain alkanes. So isomers. So number of carbon atom, that is same. Number of hydrogen atom, that is also same. So, but what is the difference? The arrangement is different. Maybe some branches will be present. So what is this one? So 1, 2, 3, 4, 5, 6. So we have normal alkane. So I have normal hexane, or I can write it shortly. How? CH3. Then CH2 is repeating 4 times. So I can write it as CH2 4 times a CH3. Or I can draw like this one. 1, 2, 3, 4, 5, 6. That is also our hexane. So in the presence of anhydrous AlCl3, in the presence of HCl, so some branched alkanes are formed. So here also number of carbon atom, that is 6. Number of hydrogen atom, that is also same. Molecular formula, that is same. So isomers are formed. Some new branches are formed here. Then one more example. So 3-methyl pentane, here 2-methyl pentane, etc. form. Actually, there is mechanism also in the presence of AlCl3, normal hexane. It will form some carbocation. Intermediate is carbocation. Then if carbocation is formed, stability of intermediate is very, very important. Suppose primary carbocation is formed, it will try to change to tertiary carbocation. Why? Tertiary carbocation has more stability. So some rearrangement will take place in the carbocation. So rearrangement, initially normal hexane. So carbocation, then some rearrangement to become tertiary carbocation. Then that time some branches will be formed. So that is all about isomerization. So we are not studying about the mechanism. What is the mechanism involved? Then what is the role of AlCl3? We will study it about this one later. Okay, this AlCl3 you have to remember, that is very important. So I will repeat about some information regarding our AlCl3. Okay, so that is our isomerization, chemical properties of alkanes. Then we have aromatization. So we will study about aromatization now itself, right? So why should we waste our time? I have an alkane. What's the general formula? CnH2n plus 2. Oh, lot of things are present. 773 Kelvin temperature, 10 to 20 atm. Then catalyst are present. Cr2O3, then oxide of chromium, V2O5, vanadium pentoxide. So vanadium pentoxide you have studied, right? Then oxide of molybdenum is present. Then in the presence of all these things, our alkane is getting converted into benzene and its homologous. Maybe it can be toluene. Toluene means benzene ring and CH3, right? So it is not clear, right? So we have to take the example. So I have an alkane, normal alkane I have. Then condition, number of carbon atoms should be greater than or equal to 6. Then carbon benzene means 6 carbon atoms are present. So that is why. Then example for you. So I have a aliphatic chain, open chain is present, right? So how many carbon atoms? 1, 2, 3, 4, 5, 6. So 6 carbon atoms are present in the presence of this catalyst. Then high pressure, high temperature, dehydrogenation and cyclization. So what do you mean by dehydrogenation? I am removing some hydrogen. What is decarboxylation? I am removing carbon dioxide. So I am removing some hydrogen from here. So what will happen? CH3 is present. I am removing one hydrogen from here. Then one hydrogen from here. Carbon, it is tetravalent. So it needs 4 bonds. Then what will happen here? So this is our reactant. This is our reactant. I am removing one hydrogen from here, one from here. Then that is removal, dehydrogenation. Then one bond will be formed between these 2 carbon. Carbon should be tetravalent in nature. So cyclohexane is formed, right? In that, how many hydrogen atoms are present? Hydrogen, hydrogen. Here also 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen. So in the first step, I am removing one hydrogen, that is minus H2. Then I need to make benzene. How to form benzene? How to form benzene? From here, benzene is formed. So I'm removing hydrogen, one hydrogen from here, one from here, one from here, one from here also. Then carbon should be tetravalent. So in that case, double bond will be formed between some carbon atom. So what I will get? I will get a benzene ring. Then double bond is present here. So that is a final product. So cyclization is formed. So first dehydrogenation, I'm removing hydrogen. Then after that, cycle is formed. Closed chain is formed. From open chain to closed chain, cycles are formed. So dehydrogenation and cyclization, that is formed here. So I will give you one homework question for it. So one homework question, I have this one, and here one methyl group is attached. So what is a product obtained? 773 Kelvin is there, 10 to 20 atm, then dehydrogenation and cyclization will takes place. Here, what is the product obtained? That is our benzene. So how to do this? Then carbon, some hydrogen, remove that. Then some cyclohexane type. Here cyclohexane is formed. Here what will be formed? You know that how to name that one. Then cyclization is formed. Then hydrogen is removed. Then double bond will be formed. It will be a benzene derivative. So that is a homework question for you. We will stop it here. So you have to find the product of this reaction. So here one methyl group is attached. That is a difference from this example. So what will be the product? It is not benzene. It is somewhat similar to benzene. Benzene is the, some group is attached to benzene. So you have to tell me the answer in the next class or in the chat box. Okay, students. So we will close it here. It is already 6 o'clock. It is time to say tata, bye-bye. Okay, then we will see you in the next class. Okay, then bye-bye, YouTube friends. So many students are there in YouTube. Then bye. We'll see you in the next class. Bye-bye. Happy learning. Happy Pongal. Happy Sankranti.